Okay, this video has the solutions for the free response questions that have to do with section 6-7, rectilinear particle motion, using integrals and derivatives. The first part of this problem, they just want us to graph the velocity function. They gave us that, so I made sure that I'm in radian mode. So let's see, it'd be e to the 2 sine x minus 1. Careful with the parentheses there, right? You have to close that whole thing. And before I graph that, I'm going to change the window to a window like what they have here. Looks like we want x values from 0 to 16 and y values from -8 to 8. And everything's scaled by 4s, so let's make our scale the same too. Let's make the scales on both of them just like their graph. Okay, so let's see if we can get that detail down. Looks like it peaks around here. You should have this graph on your calculator too, so if you can't see mine, that's okay. Peaks somewhere around here, not quite up to 8, and then it crosses just before 4. I think I made that a little too far over. And then crosses over again somewhere around here. Looks like it peaks again around 8, right? Because I set my scale the same way, so that's pretty easy to see. Then it dives down right around here, comes back up again right after 12, and then peaks again and comes back just before 16. So something like this. Yeah, it's not perfect, but hey, not too bad. Okay. Part B. During what time intervals of time is the particle moving to the left? Well, this is a graph of velocity, so right is positive and left would be negative velocity. So these are the intervals where it's moving to the left whenever it's below. And we're talking about from 0 to 16. So let's see if we can find where this graph crosses the horizontal axis, which would be the time axis. Second, calculate 0. Let's move the cursor around here and see if I can find. Let's see, the first one happens here at, that'd be 3.574. To oops, I'm not sure what I did there. Let's go back to the graph. Calculate, I'm looking for another 0 now. It's my left bound, right bound, 6.283. So that's this little interval here, and then there's another one here where it's below, where the velocity is negative. So I can calculate another 0. So from it'd be 9.425 to 12.566. You do have to round, right? Don't just stop writing the number down. Look at the next one, go up or down, depending on what you see. And then last, it looks like it does actually cross again, just at the end there. Right bound, we'll just go just barely past that. 15.708 to 16, right? They only wanted us to go from 0 to 16. So these are the intervals where it's moving to the left. Why? Because velocity is negative on these intervals. Okay, find the total distance traveled from 0 to 4. Well, that's the area. Remember, this is total distance traveled. So that means we have to find the area under the absolute value of that. So we're looking for the integral, 0 to 4, and the absolute value of the velocity function. And we'll do that using the calculator. So let's go ahead back to y equals. I'm just going to throw a set of absolute value signs around the whole thing and graph that again. You can see those get bounced up. And I want the area under that from 0 to 4. It's thinking. Why so slow? Oh, there we go. Looks like 10.543. Okay. Good idea to actually show this so they can see what you're doing. As you might get a point for having this even if something went wrong with the calculation. Okay. Is there any time from 0 to 16 at which the particle returns to the origin? Well, at time 0, it's at the origin, right? So this is all moving to the right, and then a little bit of moving to the left, and then moving to the right, and a little bit of moving to the left. So the answer is no, because this movement to the right is more than this movement to the left, and then it moves even more to the right. So it never, the area underneath never makes up for the area above. So how are we going to justify our answer? Because, let's see, how should we justify that? Area above the t-axis is always greater. Therefore, there's more movement to the right. So if it starts at the origin, it never gets back because this is moving, this area is bigger than that one, and then it's just more and more right. Well, more right, a little bit left, more right, a little bit left, but it would never get back. Okay. Oops, sorry, you can see my graph bleeding through there. Okay, we got our calculator active on this one again. An object moves along the x-axis with an initial position at time 0 or at position 2. The velocity of the object is given by this. What's the acceleration at time 2? Well, acceleration is the derivative of velocity. So acceleration would be the derivative of that, which is cosine of pi over 3t t times the derivative of what's inside, which is pi over 3. And plugging 4 in, that's cosine of 4 pi over 3. Let's see, where's 4 pi over 3? That's here. Cosine is the x-coordinate. That's negative 1/2 times pi over 3. It'd be negative 2 pi over 3. But this is a calculator active problem, so we could actually do this. If you can use your calculator, well, why not? So what if you just wanted to find the derivative of this at 4? You can do math, 8, that's derivative of sine of pi x over 3 comma x. Remember, you always need that comma x. And we want to find the derivative at 4. And that gives us negative, that does not look like it agrees with my answer. I'll have to go back and check mine. That gives me, let me just make sure that that's right. That's the derivative of sine of pi x over 3 at 4, right? And I don't think that that's equal to this, right? Negative 2 pi over 3 would be equal to that. So let's see what we did wrong here. Oh, I did 2 times that. Sorry, it's negative 1/2. So that's what I did wrong. Sorry, negative 1/2 times pi over 3 is not 2 pi over 3, it's a negative pi over 6. And I bet that is equal. Let's try that. So negative pi over 6. Yeah, that's right. Sorry about that. So let's write that more clearly. Negative pi over 6. Or negative 0.524. And that's fine. If the calculator is allowed, then you can absolutely give that decimal answer. Round to 3 decimal places. Okay, consider the following 2 statements. For times 3 to 4.5, the velocity of the object is decreasing, or the speed of the object is increasing. Are either or both of these statements correct? For each statement, provide a reason why it is correct or not correct. Okay, so statement 1. It says the velocity is decreasing. Well, velocity is decreasing. That's the same as saying acceleration is negative, right? Your velocity is decreasing when your acceleration is negative. So, is that true? Acceleration is cosine of pi over 3t times pi over 3. So we could graph that. Let's go ahead and do that. It's cosine of pi over 3 x times pi over 3. And since I want to know from 3 to 4.5, let's go from 0 to, I don't know, maybe 0 to 6. Maybe a good window. And let's scale it by 1.5. Oh, I could scale it by, yeah, I'll scale it by 1.5, because then the second mark would be at 3, and the third one would be at 4.5. And let's see what it looks like. So that's 1.5 right there. That's 3. That's 4.5. That's the acceleration. So in fact, the acceleration is negative. So that statement is true. True because acceleration is negative on the interval 3 to 4.5. How about about statement 2? The speed is increasing. That's speeding up. Well, speeding up and slowing down we figure out by if the velocity and the acceleration have the same sign. If they have the same sign, then the speed's increasing. So let's see. We know that acceleration is negative. So let's see what the velocity is doing. Go back here and just put in our velocity curve. That's sine of pi over 3 x. There's our velocity curve. And it looks like from 3 to 4.5 the velocity is also negative. So they're both negative on that interval. So the object is speeding up because those have the same sign. They're both negative. So it's true. Okay. I suppose the naive thing one might think about this is the velocity can't be decreasing and the speed increasing, but we know that speed and velocity are not the same thing. This is the absolute value of velocity. So they can both be true, and we found that they are. What's the total distance traveled by the object from 0 to 4? Let's see, total distance traveled is the integral of the absolute value of the velocity function. And we should definitely write that down. So I've got the velocity function in there right now. Let me throw some absolute value signs around that. Graph it again. Now all the places where it's negative, you can see it gets bounced back up. And we want total distance from 0 to 4. So second calculate, go number 7 from 0 to 4. And we wait for my TI-83 small brain to give us 2.387. 2.387. And that might be some nice kind of multiple of pi, but hey, we're allowed to use our calculators here, so that's all right. Part D, what's the position of the object at time 4? Well, to find position, we're going to do the integral from 0 to 4 under the velocity curve without the absolute value signs. And that would be equal to, since position is the antiderivative, that would be position at 4 minus position at 0, right? Well, we can find this using the calculator. We can go back into y equals and remove the absolute value sign, delete that, and get rid of that last parenthesis. And then here, now I'm finding the displacement. This is how far it actually is from where it started, from 0 to 4. So that little bit of area here is going to be negative now. It's a 1.432. 1.432. Okay, now, that's not the right answer because they told us at, I used S here and they used X, so I should be consistent with theirs. Sometimes they use S, sometimes they use X. We know that X of 0 is 2. So this gives me the position at 4 minus 2, that's what X of 0 is, X of 0 is equal to 1.432, so the position at 4 is 3.432. To kind of make common sense of this, think about it this way. The position at 4 is whatever its displacement is plus where it started, right? That's why we're adding the 2 over here. This is how far it is from where it started, and where it started was 2. So, get 3.432. That's about 20 minutes, so I'll put the other two in another video.